So let's take a look. Well, before we go, okay, so I passed that back, and I created a second arm segment, which is the forearm, and I placed it a little bit more to the right. At this point, these two would be free-floating, not attached to each other. Then I created two joints. I created a pivot joint, which connects this body to the torso. And this is why I have the markers, because the markers are placed over the ends of the body. So there's a marker here and a marker here. Those positions are where I want the joints to be. So it's a pre-calculated position. My little arm builder has basically told me this is where that joint needs to be, and this is where that joint needs to be. And so what I do is I attach the bicep to the, I attach the bicep to the torso, and I place the pivot joint where the shoulder X and Y are. So if you go back and look at the code, you can see that I have a shoulder marker, and that gives me the X and the Y position for the center of that pivot, which is saying that this body, regardless of where it may be positioned, will be attached right here. It's kind of weird. It's kind of interesting and weird and very useful that you can place the joints anywhere relative to the bodies. So for example, as you can see, you may be able to see in this image, these little markers here are where the joints are, and I've kind of placed them all relative to the centers of the bodies. But a joint can be anywhere. For example, let's turn on gravity. I've got a touch joint going on here now, and as you can see, there's a dot here where my cursor is, but there's another dot sort of off-center. The point is that joints can be anywhere relative to the bodies, and so placing a joint at the center of a body is fine, but you may want other behaviors, and so you can place that joint anywhere. And when people are first doing this, they sometimes place their joints incorrectly, and then they're like, why is my body moving strangely? It doesn't make sense. They get strange body motions. So what you need to do is turn on hybrid mode and take a look at these little lines that are drawn between joints, between bodies and their joints, to see what is really going on. So in this case, the two distance joints are connected directly to the center. And we know that that's basically what I know as I wrote the code, that's what I was hoping to achieve, and so it's correct. Let's go back.
Is there a situation where you would want the touch joint to be outside of the object itself?
Absolutely. So think about a lever. How does a lever work? A lever acts upon a body and moves it through some kind of force. And so you may want to create a situation where the body is swinging around a point, but you want that, I don't know, how do you describe this? It's weird. I know what I want to do, but I can't describe the reason I want to do it. I'll say yes. There are cases where you would want the joint to be outside of the body. It's not typical, but it does occur. Most people want the joint to be in the body or in the same position as the body, and typically in the center, but not always. Like
I was thinking of you think major magnet? You think that was something that they used? I know that was, you kind of touched where you wanted the.
They could very well. I'm not 100% sure, but if we look at the joint sampler, there's a thing called a distance joint. Yeah. Let's turn on hybrid mode. And a distance joint, what that's saying is object A and object B must always maintain the same distance. They can have a different rotational orientation to each other, but they're not allowed to get any closer. And so I think in major magnet, because your character goes around the magnet in the center,
yeah,
and it does so as soon as you touch the screen. So what they could have done is they might have created a a distance joint, and then what would happen is object A, let's say that's the dude flying around, and object B is the magnet, then uh, object A would have been flying around here and would have maintained its, it's hard to do because they're both allowed to move in my example, but would have maintained its velocity, and that would have turned it around the shape. Now, I can tell you right now that's not all I would have done.
Oh, sure.
Uh,
Because you're jumping from magnet to magnet, which means.
well, right. So, okay. Uh, let me just go change this example so I can show you exactly what's going here. Distance.
And that's okay. I was just curious, that way people could kind of think outside the example
Hold on.
there.
While he's making these changes, I think the important thing that everybody needs to remember when you're working with any kind of physics joint is create a small example of what you're trying to do and experiment with it for getting your settings right, and before you're implementing it into your full program. Little bitty demos, not that what Ed has created here is a small demo. This is actually a huge demo with all the inner workings that he's got in here. But the important thing is try the joint in a smaller version of your program for what you're trying to accomplish, and experiment with it in that smaller relationship to make sure that you get the reaction that you're looking for.
Absolutely. People ask questions in the forums, and they're confused because something's not working, and I typically tell them, all right, go make yourself a small test bench that does just the thing you're trying, and then see if it works the way you think it should.
And that applies to everything. It's not just physics. It's anytime you're trying to do something new that you haven't done before, take the time to build it in a smaller program with just that feature. Once you start putting all these features together and you get all this interaction between various features, you might have unexpected reactions to one another. So getting it working independently is that important first step to make sure that your larger program will work.
So what are you doing? You're flailing distance A around there?
Yes, I am. I'm sorry. This is like what I would consider major magnets' basic mechanic to be if they chose to do it this way. It's a distance joint, and when B is a static body, the magnet, and A is major magnet, and when you throw him around, it maintains its velocity, even though it changes its direction, and its distance to the magnet. Now, I have damping on here, but if I had no damping and I just flung it like that, it would just go around and around and around. It would never stop. And that's exactly basically what they're doing in that game. And then what happens is, consider, they're moving in a straight line, and then you do this, you create this distance joint, and then it forces the body to start traveling in a circle around object B. But then if you suddenly remove this joint, the velocity will be whatever the velocity was on the last frame, which is going to be a straight line, and it will fly off in that direction. Now, I kind of think they did not do it this way, and the reason I think so is because I've experimented with these things, and it's kind of tricky to get the timing to match what the user expects, because there's a slight latency between the tap, the removal of the body, and the response that you expect. Now, maybe they did this and they worked it out. Maybe they changed the number of iterations per second, something. But in my experimentation with things like this, it didn't quite work the way I wanted it to.
Yeah. And he does, Major Magnet does continually spin around the magnet. He doesn't slow down and just sort of hang there if you don't do anything, at least not in my experience.
That's right.
So.
Exactly. So let me put this back.
Okay. Well, cool. Does anybody on the panel have any questions or anything to add?
Yeah, we didn't quite get to the end there, but I think we can leave it.
Okay.
We can leave it. Really wanted to talk about the car example. The car example is so much more fun.
Well,
it's kind of boring.
Well, we can start off with the car example next time.
Yeah, I just want to turn people in the right direction here as far as the dog goes. So the key here is you need to go look at this create arm segment or create leg segment function, which is down towards the bottom of the file. It's a little bit hard to read here as I navigate. And basically what it does is it creates the rectangle, it creates some circles, it mounts the circles to the body, that is the rectangle, and then it just passes them back. It's a very simple builder that creates a certain length, certain position, passes it back. So it looks very complicated. It's because this code line is so long. But there they go. I made it simpler by making it smaller. Just read through the arguments, and it will become more clear. This is why I did it that way, because I wanted people to say the bicep is connected to the body joint or whatever. In this group, the arm segment length and this thickness. Oh, that makes sense. I could have just put numbers in here, but it would have been totally meaningless.
Yeah, and this is good because it's self-describing code, and if you want to organize it differently in your own project, you can, but at least you get the concept down here.
And it shows you how not to do it. It shows you how to lay it out. The one bad thing I did was all those extra markers would be a terrible way to make a ragdoll game because it's too many objects. If I had a dozen ragdolls with that many markers, things would start to fall apart. So.
Okay.
All right.
Well,
I'm just going to look at the car example for fun while you guys talk now.
So next time we're going to talk about the car example and what we'll look at how it's constructed and how.
Yeah. So it's a real simple thing. It's basically a body and a pivot joint. The only thing I wanted to talk about was how you do the motors.
Okay.
The little bit where you make it drive around.
Yeah, let's definitely talk about that next time. Again, I could kind of. I mean, we said this last time, but I can kind of see a simple game just in what you're doing there. I mean, it seems like.
Yeah. I mean, this is exactly. I mean, what was that game that came out 4 years ago? Was the one where the jelly wheel thingy, jelly car?
I don't remember that one. Does anybody remember that one?
No.
Jelly car.
It was wildly popular.
What was the premise of it?
Sir?
What was the premise?
It was a car whose you could change the size of the wheels and I think the body, and it had to navigate a world that basically it had to navigate a world under its own basic power, and it would tend to tip over and stuff like that, and all you could do was modify like the size of the body and the wheels to navigate the world. It drove at the same speed. The wheels turned. It wasn't under your control, and so all you had to do was like get the right size at the right time. But it was a wonderful example because what they did was they had soft body physics mixed with basic physics like we've got here. We're just rotating joints and stuff like that. So.
Did that one go over hills and stuff like that? Did it go?
Oh yeah, over hills and through gates. And
I may remember that one vaguely.
Yeah.
Yeah, that sounds like a lot of fun. So yeah, I could see catching things from the sky and having that alter the way that the cart interacts with the world, and then adjusting gravity periodically just to mess things up and try to maintain your load. Yeah, that would be cool.
Yeah, I mean, I did this example. I'm like, I don't want to do the show anymore. I want to go make a game.
Yeah. I want to go play with my cart.
I just want to play with my car. I don't even want to make something. I just want to play with it. I do. I find myself like, watch this. Let me reload it.
Well, who doesn't just want to play with their wagon, right? I mean, come on.
I discovered something I didn't know. So this body is attached to this body, and it tries to keep it in place, but if you spin the tire, the tire's got momentum, and the momentum bleeds off into the joint, and it causes the body to rotate because there's no gravity.
I see.
I did not know that.
That's an interesting. See, there you go. That's a Space Odyssey type game. All right. We'll talk about more of that later next Monday. So be sure to tune in for that, and also be sure to check the show notes for links to this example. So all the code is here. It's all provided. And then I definitely recommend that you go watch last week's show. There's a lot of great tips talked about there, and don't miss it. So we'll be back here next Monday at 12 p.m. Pacific to talk all about mobile app development using Chrome SDK. Till then, have a great week and happy coding.